Yes. Yep. So, um, yep. So here's what we have. Yesterday we talked about derivative, and I said if it takes me a half an hour to get from here to Owatonna, and it's 30 miles, then what is my average speed? 60 miles an hour. All right, so that's average speed. That's my average rate. Average rate of change over the course of that time frame. However, if a cop gives me a speeding ticket and I'm going 77 miles an hour, that means at some instant I was traveling at 77. That's the difference between a derivative and an average rate of change. So let's understand this. It says the temperature of a pot of water is modeled by the function C equals F of M. C is in degrees in Celsius and M is in time in minutes. So who likes mac and cheese here? Okay, my daughter right now, she thinks she should make mac and cheese for every meal. So no, Kira. So she's got the stove and she puts the pot on the stove and it's got water in it. And the fact is that the water starts at, say, 56 degrees. And that maybe is at time 0. And at time 5, it might be at 112 degrees. And at time 7, it might be at 210 degrees. And then at time 9, it might be at 211. It's really tough to get to that last degree. Then finally at 10 minutes or so, it's sitting at 212 degrees. But the temperature is going up as it's sitting there and heating up. It says explain in simple terms what f prime of m means. F prime of m means the following. At m minutes, this is so important. You say at m minutes, because again, it's like when I'm driving home, at a certain time, I was going 77 miles an hour. That's your instantaneous rate of change. That's your derivative. At m minutes, the temperature of the water is changing at a rate of and here's where we need to decide a rate. A rate is something over something. So if I'm going to measure the rate at which the temperature is changing, how would you measure that? What would be your label? What am I measuring? What's the temperature being measured in? Degrees per minute. As time changes, the temperature changes, right? Look here. As the time changes, the temperature changes. Okay? It says a small t, I should use M for minute maybe. I guess I could use C for Celsius. So at n minutes, the temperature of the water is changing at a rate of C degrees per minute. So there are some really important pieces here. Number one, at n minutes, you need to state the specific time. Second of all, you need to state what is changing. It's the temperature that's changing. And then finally, you got to have a rate. Those are three pieces that are simply a must. So explain in simple terms what f prime of 5 equals 10 means. That means at 5 minutes, the temperature is changing at a rate of 10 degrees Celsius per minute. I had some students a few years ago. We got to test, and they said, well, you marked it wrong, but Mr. Jens, I basically have the same thing. I'm like, what did you have written down? They said, well, I just wrote down that after 5 minutes, the temperature has risen by 10 degrees. That's completely incorrect. 100%. It maybe has gone up 100 degrees. It's maybe gone up 2,000 degrees. You have no idea how much it's increased overall. You just know at that point, it is going up at a rate of 10. That's all you know. picture this. Marty's driving home. Marty, how fast are you going? Come on, trick question. If he was going to say 45, I was going to say, in a 30? Crazy man. Give me a number. Come on. 30 in a 15? Holy cow. He's going 30 miles an hour in a 15 zone. All right? 30 miles an hour in 15 zone. So if he's going 30 miles an hour in a 15 zone, do you know how far he's driven? Do you know his top speed? Do you know his bottom speed? Do you know how long he's been driving for? You see what I'm trying to say here? It's a little bit different. All right. Example 7. You try to work that through on your own. Talk to partner. Go. Okay. At h hours, the runner's distance is changing at a rate of d miles per hour. So f prime of 3 equals 5 means at 3 hours. So after he's been running 3 hours, the distance is changing at a rate of 5 miles per hour. That means that his speed is 5 miles per hour. Okay? Here's what you can't say. His speed is increasing at a rate of 5 miles per hour. It's again, this says distance. So that's the output that you use at that time. Okay? And example 7, we're going to go straight to letter B. Mass of a radioactive isotope is modeled by G equals F of D. G is the mass measured in grams, and D is the time measured in days. At what? At 2 days, the mass is changing, or you could choose to say increasing or decreasing. Would you say increasing or decreasing at this point? I'm going to say decreasing. Decreasing at a rate of 0.34 what? Grams per day. Make sure that you include these things at that specific time. What is changing? I chose to say decreasing, so I didn't need to include the negative because it is decreasing. Okay, at a rate of 0.34 grams per day, make sure that you have a label. Are we clear? Okay, you're going to take about 15 minutes and you're going to work through your assignment that you got yesterday. We're going to come back together and we're going to introduce what we're talking about tomorrow. We good? Go. Okay, problem number 9 says let F of T be the temperature in Fahrenheit in Dallas. So this is a problem that you would see straight off of the free response part of the AP exam. And it really is a good assessment of whether or not you understand the concept of a derivative and estimating its value. So F is the temperature in Fahrenheit in Dallas, T hours after midnight on June 2nd, 2001. Table shows values of this function recorded every 2 hours. What is the meaning of T prime of 10 and estimate its value? Well, first of all, T prime of 10 means well, if it's 10 hours after midnight, what time is it? At 10 a.m., the temperature is changing at a rate of T degrees per hour. So our measurement is in hours. We're now going to estimate T prime of T. We're going to estimate T prime of 10. So we've got really 2 pieces here. Number 1, we've got a table. Then I kind of put the table into a little bit of a graph. So I'm saying that the graph of the temperature looks something maybe like this, okay? Not real exact, but it's saying what's T prime of 10? Well, first of all, can you tell me, is T prime of 10 going to be positive or negative? Positive. Definitely positive. So temperature's increasing at 10 a.m. As you look at the data here around 10 a.m., are you kind of convinced that the temperature is increasing? Why? What tells you the temperature is increasing? Yeah, you're going 72 to 81 to 88. Now I want you to just glance at this. 72, 81, 88. About how many degrees is it going up? You're saying about 9? About 8? Why did you say 8? Okay, so Lexi's doing a really good job here. She's saying here is going up by 9, here's going up by 7, so about 8. So about 8 every how many hours? Every 2 hours. So if it's going up 8 every 2 hours, is increasing at a rate of 4 degrees per hour, we would say, approximately. Now, here's one other way to think of it, folks. If I want to estimate the slope of the tangent line here, sometimes a great option is to consider the slope or the 2 points that exist around it. So I'm going to consider the slope of that line. Would you agree that the slope of the line connecting these 2 points estimates the slope at that point right there? So let's do it. What's y sub 2 there? What's the y value here at 12? 88 minus, I'm going over by 8. 72 divided by, what's the x values? 12 minus 8. So 88 minus 72 is, what, 16? 16 over 4. So t prime of 10 is approximately 4 degrees per hour. Now, there's a number of ways in which you might approximate that. This is one way, to use the point before it and after it. That's really usually the best. You might use 2 consecutive points, using the 10 in the middle. I like to use the one before and after, and that's what the AP exam recommends as well. Okay? Go ahead. Take a few more minutes. In about 5, we're going to come back together, and we're going to move on in our notes to prep for tomorrow. Okay, here we go. Now we get away from the practical application, and we are straight back towards the raw abstract mathematics. So turning your notes to this page, definition 1 of the limit had to do with this. With a function f of x, and we had a point A. Somebody tell me what's this location here? F of A. We chose then another point. We called it x. So what is this location here? F of x. We said if you want to find the slope of the line tangent, then first consider the slope of the secant line. So we used the quotient f of x minus f of a over x minus a. That gives us the slope of the secant line. Slope, super easy. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. But how did we end up finding the slope of the tangent line? What did we do? There's something missing here. What do you have to do with x? Move it closer to a. We do that by simply just slapping a limit on. It's a good thing. The definition I told you yesterday that I want to look at again so you remember it. This is more the formal definition of the derivative. This would be definition 1, which is often referred to as the quotient rule of the quotient limit rule for the derivative. This one is the derivative at a point. We choose a. This is f of a. I choose another point, which is a plus h. So this is f of a plus h. Same drawing, same idea. This is y sub 2, or f of a plus h, minus what? F of a. Oh, Smartboard just got stupid. Come on, smartboard. There we go. Minus f of a over yh. That's the difference between, so this distance right here is h. And so a plus h minus a just gives me h. Well, if we want to find the slope of the tangent line, not the secant line, what has to happen to h? If we slide this closer to that, what happens to h? Yeah, so we take a limit and we move h towards 0. So that is equal to f prime of a. The derivative at a of a function is equal to that guy. And that's where we start. Let us now use that definition. I prepped you for this last year. I think you should do just fine with it. The question is, we have a function, 3x minus 2x squared, and you want to be able to find the derivative at 3, or the slope at 3. Slope equals derivative. Use definition to find equation, definition 2, find equation for line tangent. I need the slope, and I need a point. The point, I choose 3 for x. What do I choose for y? Plug it in. I got 6 minus 18. I'm sorry, 9 minus 18. Negative 9. Slope, easy. F prime of 3. How do we find f prime of 3? We use this guy right there. I plug a plus h in. So I have the limit as h goes to 0 of, I plug in a plus h for x. And I get 3 times the quantity, a plus h, minus 2, you stupid dumb board. It's red. Always turns red when it gets mad. Minus 2 times a plus h squared. So I just plugged in a plus h. Now what? Minus what? What is f of a? What is f of 3? So it's a plus 9 on the end here. All divided by h. You could try plugging in 0 right now. Do you know what you're going to get if you plug in 0? 0 over 0. Just like we always. So we got to make this thing work out here. I've got the limit as h goes to 0 of what? 3a plus 3h minus 2a squared minus 4ah minus 2h squared, because a plus h squared is a squared plus 2ah plus h squared. You got to distribute the negative 2 through. We got that plus 9 on the end. My mind went to that. It has in the past. Sorry about that. Minus. Sorry about that, folks. I need to plug in f of a, so it's just the function with a plugged in. So if you plug in a, what do you get here? 3a. And it's because it's subtraction, it's then plus 2a squared. All right? So instead of that 9, I'm going to have a minus 3a plus 2a squared. All over h. What do you notice happens? The a's go away, or the negative 3a goes away. The 2a squareds go away, right? Does everything else have an h? So we can divide an h off, correct? We get the limit as h goes to 0 of 3 minus 4a minus 2h. Okay? Plug in 0 and what do you get? 3 minus 4a. This, if you plug in 0, this guy goes away, right? So this is my derivative. This is f prime of a. But we want to know the derivative at what value? At what a value are we working with? So we plug 3 in and you get -9. So that's my slope. Write the equation for the line. Y minus y1 is equal to m times x minus x1. So y plus 9 is equal to -9x plus 27. Y equals -9x plus 18. Now I could graph that, and it will be tangent. You good? Question? Exactly. So, yes. We will pick up with this tomorrow. I'm going to hand you out the worksheet that you're going to get tomorrow in case you want to start on it today. Okay?